Hello health science students, this is Professor Van Dyke with your week 14 video. This is going to be one of two videos, so we're going to cover solid waste and we're going to cover hazardous waste after that. So this is the first video. So one of the things that I want you to know about solid waste management is that you have to have an approach to it. This is slide 1. You really have to understand how much waste you're going to be generating and collecting. You have to understand transportation. You have to understand where to store it, where to put landfills, things of that nature. So it is a large program, but certainly from a standpoint of monetization of environmental health, solid waste is really one of the most lucrative businesses, which is why you see municipal waste companies had begun to appear, like Waste Management. Companies like this began to take over for cities that used to run their own programs. So they should be safe and sanitary and aesthetically acceptable. So you don't want to have one of these in the middle of a town where it smells up the whole town. So you think about prevailing winds and things like that. But it also needs to be economic and environmentally friendly. So it needs to be something that can be affordable, sustainable, and good for the environment. So solid waste management is really important and very hard to try to manage from top to bottom, but certainly a very important part of how we as a society can look to ourselves and say we do a great job because I don't smell trash and refuse and things like that all over the place. So very good. So on to slide 2. We have solid waste essentially comes in a lot of forms, which includes liquid waste as well, as you can see here. So with solid waste management, some of these things can actually take the form of liquid waste in the form of sewage. But generally with when we think about solid waste, we think of solid materials like refuse and biosolids and things like that. But it also produces gas like methane and carbon dioxide. We have different kinds of waste. We have biomedical waste and chemical and radioactive, and certainly a lot of municipal waste and business generated waste and agricultural waste and things like that. But we definitely have to separate this off into forms of safety. Is it hazardous or is it non-hazardous? Is it infectious potentially or non-infectious? And those are things that we would consider with our forms of waste. On to slide 3. So solid waste by source. We have agricultural waste like animal and crop husbandry. So we do have a lot of fouled agricultural waste like crops that may be potentially have bacteria in them, things that are negative, so they will go into the solid waste stream. We also have domestic waste, which is coming from residential sources. So every time you take your refuse outside and put it on the curb, where does it end up going, right? It goes to a solid waste landfill. And then we have industrial waste, which can be toxic or non-toxic. We have waste tires, which are a challenge to deal with, and then miscellaneous additional waste on top of that. Moving on to slide 4. So with miscellaneous waste, we have things like electric waste, the e-waste, packaging waste, certainly I got a lot of that these days, household hazardous waste, paper waste, plastic, glass, used furniture, food that we discard, old, all kinds of stuff. Certainly a lot of construction and demolition waste. So when you knock down a building, what do you do with that? Where does it go? But a lot of e-waste, and that's something that we have to deal with currently, that we have all this e-waste. What do we do with it? Because there's still a lot of very usable material within that e-waste, and we don't want that ending up in a landfill somewhere. Certainly with packaging waste, a lot of packaging waste coming from companies that deliver directly to your door with cutting the store out, it's essentially. So a lot of packaging waste as well. So on to slide 5. Solid waste management definitions. So a couple things. You'll notice that the word trash does not actually appear on this slide because we don't really consider anything to be trash. We have rubbish and we have garbage. So with rubbish, we're dealing with non-decomposable inorganics, and certainly there's a lot of plastic that goes along with this. And then we have garbage, which is things that can readily be decomposed, organic materials like banana peels that you throw out in the trash, food and things like that. And at one point we actually used to be able to dump this stuff right in the ocean, but thank goodness for the Marine Protection Research and Estuaries Act of 1972 that outlawed dumping in the ocean as of 1976. So thankfully for that, we're not dumping our garbage in the ocean anymore, and that only occurred in 1976. So that was just a couple years after I was born. So you think about it, I mean, we've been dumping garbage in the ocean for a long, long time. On to slide 6. When you think about historical components of refuse, solid waste management, it goes all the way back to 500 BC and probably much more before that, because you actually had seen cases where cavemen would take the waste of their kill, essentially the bones and things like that they had already chipped open and had removed the marrow, and they would throw them down into a pit. So when you look at this here, you know, it essentially says that 500 BC was the first dump. You know, it is actually as old as humanity itself, because we've always had to deal with how to manage the waste that we produce. So in 500 BC, the city of Athens used to actually employ scavengers, and they would take waste and they would dump it no less than a mile from the city wall. So they would take it out and they would dump it beyond the city walls, and they would actually scavenge through them and pick out the things that they could actually use. So that was how they were essentially rewarded for their position. And then in 1338, fast forward, almost 2,000 years, you have the English Parliament banning waste being dumped into public waterways, which was something that they used to do fairly regularly, and we did until 1976. They said, you know what, the Thames River is disgusting. You can almost walk across it because of all the refuse. Let's stop throwing stuff into the waterways. And then in the 18th century, the Industrial Revolution came along and really generated some problems in regard to trying to deal with municipal waste, solid waste streams that were coming out of the Industrial Revolution. So like with Eli Whitney's cotton gin, it very rapidly produced a lot of fouled material that could not be used. And what did you do with that? You know, where did it go? And that was trying to manage that solid waste stream could be a real challenge. On to slide 7, continuation of history. In the 19th century, Europe and North America really began wrestling with these issues of dealing with that. You remember the J curve of human population growth. How are we going to manage all this solid waste? And then in 1934, the Supreme Court banned municipal waste dumping at sea, but this was all municipal waste. It didn't really specifically deal with garbage, as you remember, which is decomposable. So this was dealing with really more of us just going out and dumping all kinds of stuff. Now, did that stop us? Absolutely not. And certainly you see a lot of that with all kinds of different things, like we used to dump DDT off the coast of California here. So in 72, the Marine Protection Research and Estuaries Act prohibited ocean dumping of industrial waste, sewage, sludge, radioactive waste, radiological waste, chemical, biological warfare agents, because, yeah, in fact, these were things that we actually did do. A horrible use of our oceans to try to just forget about the things that we didn't want to deal with anymore. So very dangerous process. Slide 8. This was the... Hey, how you doing? I'll say hi to my dog. She's a total of 5 pounds. Hi. Okay, chill out. So slide 8 is the New York trash strike. And as you can see here, come here you. As you can see, trash builds up very quickly. Rubbish is something that is a monster to deal with. And you can just imagine in 1968 in the city of New York, you had rats everywhere at this point, and certainly probably raccoons roaming the city. But this was because essentially the sanitation workers were not being paid a livable wage, and they said, you know what, we're gonna walk out on the job, and you're gonna see how much you really do appreciate us. And in fact, the city of New York did do sweeping changes to the contracts for those workers to try to give them a more livable wage. On to slide 9, Resource Conservation and Recovery Act of 1976. They began looking at installing monitoring wells and methane gas to landfills. So they had to try to figure out how much carbon dioxide, how much sulfur dioxide, things like that were actually coming out of these landfills, and they found out that it was actually quite a bit. And then with CERCLA and SARA, this is the Superfund Act going into effect. They really cut down the number of landfills. In 1993, it was down substantial, and then you ended up with really a diminishing of a lot of our more dangerous landfills with CERCLA and SARA. So SARA is the Superfund Act, and essentially what they said was you need to quit dumping very toxic materials into standard landfills, because essentially the effluent, as you remember, the effluent is the water that washes out of landfills and things like that, was very highly toxic, so very dangerous for communities. On to slide 10. So what are CERCLA and SARA? These are just some definitions here. CERCLA is the Comprehensive Environmental Response, Compensation, and Liability Act of 1980, which said you people made a mess, you need to clean it up, and you need to pay for it. And SARA is the Superfund Amendment and Reauthorization Act, which said who's going to pay for it, we're going to track you down, and you will pay for the damages that you did to the environment because you weren't properly handling the waste streams from municipal waste and industrial waste as well. On to slide 11, a little bit more history. Per person average daily waste production was about 2.7 pounds in 1960, and we make about 4.6 pounds per person per day in the U.S. now. So we've almost doubled that. And, it's a lot of waste, and about 61% of it's going to landfills. Still a lot going to landfills, and about 30% of it's being recycled. But we have done a better job, certainly with putting recycling bins in areas like right next to our trash cans on campus. These are very beneficial things, and they work out very well and can generate a lot more recycled material. On to slide 12. So this is the EPA order of preference, and what that means is when you're getting rid of things and you're throwing them into the waste stream, what's the best thing for us? So number 1, source reduction. Number 2, recycling. Number 3, waste heat recovery. And then number 4, very last, is burying or landfilling. So the first one, source reduction. Can you get rid of some of the materials that you're using? Do I really need a box inside a box inside a box being shipped to me from Amazon? Probably not. So can you reduce that? Can you use less packaging? Things like that. And then the second is recycling. How much of this can I recycle? Can I reuse it? Can I take the water bottle that I have and fill it back up? So recycling is a great way to limit that waste stream, but certainly recycling itself takes energy. Reusing it is far better. Can I find a use for this and reuse it over and over and over again? And then waste heat recovery is where you'll take that landfillable material and you'll actually burn it and you'll generate energy from it. So in Europe, they're actually thinking they're going to run out of landfills because they've been digging them up and burning them to make waste heat. And then they recover that heat and utilize it for an energy source. A very brilliant strategy, but certainly burning refuse is potentially harmful for the environment as well. And then finally, burying it or putting it into a landfill. Slide 13, what is our composition of waste? So you still see about 38% is going to be paper and paperboard. So we actually thought that when everything went online that we would see a lot less paper waste because people weren't going to be reading newspapers. But certainly, all you have to do is look at a box that's shipped to you and you'll find where our paper waste is coming from today. So it has stayed pretty much the same. So we still use a lot of paper waste. We also have a lot of yard waste and grass clippings and things like that. Food waste at about 10%, and plastics at about 10%, and we throw away some metal and some glass, a little bit of wood and things like that. But still, paper and paperboard is still one of the, paperboard's cardboard basically, and it still dominates what we're throwing into the solid waste stream. And then disposal methods on slide 14. How do we get rid of this stuff? Excuse me. So disposal methods, we have landfilling, so we just take it out to the landfill. We also have sanitary landfills, which we'll talk about a little bit later. But we also have containerization, where we basically throw it into a container and stash it away. We actually do this with high-level nuclear waste. We containerize it. And then we have composting. So in some communities you may live in, they will actually provide you with a composting bin of some kind. It usually looks like a large drum that has a hand crank on it for turning it over, and you can take your waste, like your food waste, and actually turn it into a compostable material. And then incineration is the last disposal method. So it's a good way of getting rid of things, is just to burn it up, as it takes up a lot less space. But the unfortunate thing is that burning does have an effect on the air quality and the environment. So with slide 15, as I had mentioned, we have to be strategic with where and how we manage our solid waste. So when we select a site for landfilling, some of the things that we consider is location and soil type and topography. Is it close to groundwater? Is it accessible? And where are the prevailing winds? So with location, you want it as far away from homes as possible. You don't want that stench of um, decomposition blowing into neighborhoods. You don't want it right in the middle of a neighborhood. They're quite eyesores and really are very messy procedures and have a lot of trucks coming in and out of them. So the location should be a good distance from homes and things like that. The soil type ideally is like a sandy loam, which is going to absorb water. It's not going to allow for the water to rush in and out. And so this can be challenging in the Midwest where they have high clay content in the soil. So the soil type can be a little bit of a challenge. And then you have topography. So you can use flat areas, you can use hilly areas, and you can use valleys very easily in regard to a location for a landfill. And we'll talk about each one of those. And then groundwater. Certainly you don't want it anywhere near a groundwater source because the effluent will leak into it and then that will end up going into a drinking water stream of some kind, and nobody wants to drink solid waste management effluent. That would be disgusting. And then accessibility. You want good roads going into the landfills. There are a lot of trucks going in and out of these places, but also residents going in and out as well, taking their solid waste to these locations. And then finally, the direction of the prevailing wind. You don't want the wind blowing through the landfill and carrying those gases into neighborhoods because they really are very smelly. So sulfur dioxide, as you know, kind of smells like rotten eggs. Carbon dioxide is an air pollutant, so is sulfur dioxide. You just don't want these things. On to slide 16. So with types of landfills, and again, this kind of goes back to topography, the area that you're actually going to be putting the landfill is very important. So if you have a flat land source that you're utilizing, you can use the trenching method, which is essentially you dig a big hole, you throw all the refuse into it, and then you cover it up with dirt. Then you have the area method, which is going to be hilly slopes. And what you'll do with a hilly area is you'll essentially fill in the areas between two hills, and then you'll cover those up with dirt. And then you also have the valley method. So the valley method is essentially the trenching method naturally done. So the earth, through its natural processes of erosion, provides you with a valley. You fill it up with trash, and then you cover it up with dirt. So these are the methods that we can choose in regard to the topography that we use. It's a shame to lose a valley. It's a shame to lose hills. But what else are you going to do? Fortunately, we're working very diligently to try to minimize the amount of trash that goes into these landfills. And then onto the landfill covers. So every day at the end of the day, a landfill is required to cover their active face with dirt. Okay, so the active face is where the refuse basically stops. So this is the area that people were dumping these materials, and this is the leading edge of that. So you always have all of the landfill essentially covered with dirt, so wind doesn't blow it away, so animals don't come and haul it off, and seagulls and things like that. So the active face is covered every day with 6 inches of dirt. And then the final cover for a landfill is 24 inches. Now, 24 inches is 2 feet, as you know, which is really not that much. So you don't have to dig very far to find municipal waste where these landfills used to be. So they're only covered by 2 feet of dirt. And then the height of lift, you don't want a big hill, because if it's on a hill, then the water's going to rush through and it's going to wash away the dirt, and then you're going to end up with exposed municipal waste. On to slide 17. So with slide 17, we talk a little bit about the aerobic state. So the aerobic state is going to be an oxygenated process where the solid waste is breaking down, and that's going to be from 4 to 60 days. This requires oxygen, so that's why it's aerobic. And then on to the anaerobic, which does not require oxygen. This is going to be after 60 days. And the process of anaerobic decomposition is actually going to be where these gases are produced. So now you're going to start seeing greenhouse gases coming out of landfills. So you have 65% methane, 35% carbon dioxide, and hydrogen sulfide at about 1%. These are dangerous gases. They can be very flammable. But if you manage them appropriately, you can burn these gases and actually generate energy from them. So with leachate is going to be that process where influent water runs in and then runs out as effluent, and it's going to carry with it some of the potential hazardous materials that are in the landfills. So that's why it's so important not to throw motor oil and other hazardous liquids and whatnot into a landfill unless it's a secured landfill, a sanitary landfill, and we'll talk a little bit about that too. So on to slide 18. Again, containerization is going to be where you just throw it into a container. It's very good for hazardous waste. Certainly, as you know, we don't drive down the freeway with high-level nuclear wastes. That is containerized on site. On to slide 19, composting. This is a process by which we can break down things and reuse them. So the end product is hummus from composting, not the delicious hummus that you eat with pita chips, but a soil conditioner, which is very valuable and actually works very well for generating and fostering solid growth in your plants. So composting is a great method. And then slide 20 is some of the requirements for composting. I put this in here just in case you ever feel like doing it on your own, but not really things that I test on. Slide 21 is the incineration process. Obviously, it reduces volume by 85%. There's energy that's produced, but the most important thing here is that it's not really great for air quality and things like that. Slide 22. Smokeless incineration is used by hospitals. It is very expensive because the temperature is at about 1800 degrees Fahrenheit, between 1400 and 1800 degrees Fahrenheit, and it is very expensive to run anything that produces heat at that volume. So smokeless incineration works very well for organizations that are required to use MAX. So you remember the maximum achievable control technology, MACTs. So they are going to be things that will allow for smokeless incineration and will have scrubbers to actually remove some of the pollutants from the air. And that's something that basically scrubs the air and strips the pollutants out. Slide 23. So with waste tire management, this is a real challenge because waste tires are a nightmare to deal with. They can't be reused. They can't be broken down and turned back into tires. If you can find a way to do that, you will be ultra rich. But unfortunately, the vulcanizing process does not allow for waste tires to be reused. So waste tires are a real hassle, and they need to be managed in a specific fashion. So tire equivalent means that certainly you can only put so much waste tire material into a landfill, and that's slide 24. Slide 25, altered waste tires, they can only put so much into landfills, and that's really what it comes down to. Waste tire management on slide 26 becomes a challenge. Again, you know, really what I want you to take away from this is that waste tires are a hassle to deal with, okay? Slide 27, more information on waste tires. Some of them are stored indoors and whatnot. Slide 28 is waste tire storage outdoors. It has to be specifically done because they catch water and they breed mosquitoes. They can catch on fire and burn for eternity, essentially. They have to be away from vegetation, and they have to protect from runoff as well. So if you store them outside, they are a real handful. Slide 29 is indoor tire storage, which obviously is going to take up a mountain of space and a real challenge to have to deal with. They're a nightmare again. And then slide 30, only so much of waste tires can be put into landfills. So again, you know, they really are a hassle to deal with. Slide 31, containers for waste tire storage. They're a hassle. So now think about this, okay? As I had mentioned once before, if you want to get rich and you want to figure out a way to get rich, you take something that nobody wants, that's basically a handful to deal with. It's a nightmare, right? And find a way to use it, okay? So with waste tires, what did they figure out? All right, they figured out that if you chop them into little tiny pieces, you can use them at for running track surfaces. You can use them in playgrounds so that kids don't fall and bust all their teeth out or get concussions or break bones. That was a billion-dollar idea, and whoever came up with it, in my opinion, is an environmental health hero, okay? Because it took something that no one wanted, it turned it into a product, and it made an extraordinary amount of wealth for that individual, but it also saved lives and protected people and runners' knees from running on tracks and things like that. So this was a huge invention that was just a stroke of genius. You got these mountains of spare tires sitting around, and you figure out how to turn them into money. Okay, so that's the takeaway from this. Spare tires are a nightmare. Waste tires are a handful to deal with, but again, you turn around and you make it into a billion-dollar idea. Okay, so with that, that is solid waste management. I'm going to go ahead and close out here, and then we'll move on to hazardous materials management.